construct an open top box from a sheet of paper in front of you. I gave you 2, so that way, because we're going to do this like 3 times, so maybe use 1 2 times and then the other one for the 3rd time. You're going to calculate the volume of your box and complete the table with your information. So I'm going to help you with the first cut. So you're going to take your ruler. That's why I have rulers in front of you too. You're going to measure off to the side 1 inch from each corner. So go ahead and do that right now. And when it's done, it should look something like this. Oopsies, that's not a rectangle. So you're gonna have a rectangle, and then you're gonna have corners cut out 1 inch squares. So you should have 1 inch square of each corner. Whoopsies. It should look like this. So there's my first corner. Let me get there. And then my second corner. Let me get there. They should all be 1 inch. Be better than what I have right here. Okay. Eek. And then once you have measured those, then and only then will you cut them. Okay? So take a couple minutes and do that right now. The table, you should be figuring out, well, what's my new length from here to here? And what's my new width from here to here? To the cuts. See if you can predict it. So if you're not cutting, you're predicting. And then we'll figure out the volume of the box together. Let's see if we can all figure this out together. At least for the first one. You're going to do this 2 more times. So, text box. What was my new length? 9, because I cut 2 inches off of the length. And 11 minus 2 is 9. Okay? What's my new width? 6.5. Because I was 8.5 and I cut up. What's my height? It's 1. Your height is the side length of your cutout. Okay? And when you multiply 9 times 6.5 times 1, because that's how you figure out volume, length times width times height. What do you get? 58.5. Okay. I want you to do this 2 more times, but listen very carefully to my instructions. The next cut has to be 2 inches or bigger, and then the next cut after that has to be half. So either 2.5, 3.5, something like that. Okay? So 2 more. One has to be 2 inches or bigger, and the next one after that, 2.5, 3.5, something like that. Okay? Go for it. And then fill in your table. So I'm going to make a new text box because that's not fixed. So 2, I'm taking off another inch from 9 on 2 different directions. 7. And then I'm taking off another inch from the width in 2 directions. So 4.5. And if I'm cutting off another inch, my height gets larger by 2 more. So 3. No. Okay. The height is only changing by 1. This number here should be the same as the height. So that's 2. Okay, we'll figure out the volume in a minute. I hate when it does that. Why does it keep doing that? Want my pretty blue? I give up. All right. So, did anybody do 2.5? Yeah. Okay. What'd you get, Avery? So 2.5. So what are the other numbers? 6. Because we're only taking off a half inch. 2 times a half is 1. So 7 minus 1. Okay, keep going. 3.5. Again, we're only taking off. And new height is 2.5. Okay. Anybody got 3? We got 3.5? No? You got 3.5? Okay. So 3.5. So I know the height's 3.5. 3.5. Coming back. Well, I'm going to have to take 2 more inches off the 6, right? That's 4. This is going to be kind of tall, right? So my width is going to be much smaller. Very tall. And then delete. Oopsies. Take a minute. Find your volume for these. Find your volume for these. And then you are going to graph that as X and the volume as Y using a table of values in Desmos. Okay? So you have to calculate the volume. Your horizontal axis is the side cutout, also your height. And the volume of the box is what you get after you multiply your length, width, and height. Okay, so remember, volume one more time. V equals length times width times height. Okay. So after you've calculated those, I want you to go into Desmos, graph the points, and then we'll talk in a minute. Okay. Let's put our width and our length and our height together to give us our volume. Okay. So 7 times 2 times 4.5. 60 something? 63? Next one is 50 something? 52 and a half? And then the last one, oh yeah, 14? Is that right? 4 times 3.5? Really small. Because the box is going to be very tall and thin. So now we're going to put these numbers in. 263, 2.5, 52.5, and the 3.5, comma 14. So let's go over here. Go here. Make a table. Somebody help me out. The one was 58.5, right? Okay, watch what happens. There it is, graph. And then the 2 was 53? 63, sorry. 63. We had 2.5, right? 2.5 was 50 something? 52.5, and then we had 80 bitty 4. 13.5, right? That doesn't sound right. That doesn't look right. Let me see.
It was 3.5 and 14.
Oopsies, wrong one. Don't look at that! That's our answers for later. 4 times 1 was the width only 1, really? It's 8.5 minus. Yeah, okay. So 14. So 4 comma 14.
It's 3.5.
Oh, 3.5 over here. Sorry. Thank you. 3.5 was 14. So it looks like at some point it would have peaked out. So I want you to have a conversation with your group and answer the question, where do you think the largest volume, how big should your square cutout be? Don't say it, just talk quietly. Don't scream it out if you figured it out. And then we're going to actually create an equation to justify if your answer is correct or not. Okay? So volume is open top box is the side length times which is your height, times your width, times your length. Make a plan to figure out how to construct a box with the largest volume. Go ahead and take a few minutes to do that. Okay. See how it kind of goes up and then comes back down? Let's use my little pen. So I can come up, and it's got to come back down. So it looks like it's somewhere around here-ish. Okay? So not 1, not 2. Okay, so let's see what happens at 1.5. Okay? So let's do the calculation. So go back to your table, do the calculation, and see if that's bigger than 63. Okay? So if we did a 1.5 inch cutout, what would your volume be? So go back to your table, put it in there, see what happens. Oopsies.
What's the length? Why wouldn't that be 8?
So just put it at the bottom. Okay, what would the numbers be? What's my new length? My new length, 8. And my new width is 5.5? No. Okay, 5.5. And my new height should be my cutout, right? What happens when you multiply 3 of those together? 66? That looks like that might be my biggest. Okay, this was very inefficient. Do you think there's a way we could do this without doing all that work? Okay, so let's take a look at that. So what I want you to do is I want you to take the formula that we have up here, the length times width times height, and I want you to rewrite it in terms of x. So how many variables? 1, just x, okay? So you're going to rewrite it. The volume is a function of x. So start with v of x equals. And if I have 3 things, let's just make 3 sets of parentheses. Oopsies. 3, 1, there's 2, there's 3. 1 represents the length, 1 represents the width, and 1 represents the height. So see if you can take a moment and come up with the algebraic expressions that go in those 3 boxes. Okay? And actually, this goes down here. Okay? So take a moment and do that. So you don't have to use parentheses. I just like to have it to group together, my length, width, and height. And I'm going to put my height first, because that's easy. That's x. That's how much I cut out. My length was 11, but I subtracted off 2 x's. And my width was 8.5, but I also subtracted off 2 x's. Okay? Now remember I said once you do stuff in equation, if you did this in equation, not in a text box, we can copy and paste. So ready? Control A, Control C. Go to Desmos. Control. Look at that.
I did not get that.
Okay? So if you put this in properly, it should have gone through all of the points. I still thought this one was off by a little bit, so I'm not sure where the calculation is wrong, but these are good. And how do I know, confirm that I have maximum? This is the nice thing about Desmos. Watch. When you have a bump in Desmos, it tells you, okay, something doesn't look right. It should be 8.5. 2x. It should be 8.5. It's pretty close. Yeah, it's in there. Okay. So my graph is a little jacked up, but it's pretty close. It's 66. I'm not sure what's going on. 11 inches by 8.5 minus 2. Okay. So part of this graph doesn't make any sense, though. So let's see which parts don't make sense. We're cutting things, which means it's physical. Can we have negatives? No. So we're going to make a domain restriction here. So go into that right here. We're going to put a curly brace, so right above, right next to the peak. So we can't have it less than 0, so put a 0 in there. And it really can't equal 0, because if it equals 0, ready? Here's your box. Is that a box? No. Okay, it's not a box until I have 3 dimensions. Right now, this is a piece of paper. So we're not going to use 0, so we're just going to make less than. It's still x. Take your fingy. Figure out where it crosses. The x-axis. Okay? It crosses the x-axis at 4.5, which means also I have a half a piece of paper. Do I have 3 dimensions? This is 4.5 across the top. I've got a width, then I got a length. I don't got no height. Height is 0. So I need it to stop at 4.25. So go back here, go to the right. So it's going to be bigger than 0, but less than 4.25. Okay. Questions? That's it. What should we do now? Let's save it, okay? So we're in 2.1. This is polynomials. Polynomials. You just created your first polynomial, okay? And we made a box. B-O-X, okay? Made a box. Polynomial. That is what this entire unit's about. We're going to be on this unit for a long time. Once it's saved, we are going to link it. Okay? So up here, click copy. Go back to Desmos. Somewhere around here, make a text box. Call it Desmos. Okay. Select that text. Control K it. That helps you create the hyperlink. Control V, paste the hyperlink. We save this. We click turn in, but you're not turning it in. You're just saving it. And you are done for the day.